I started the recording. All right, guys, so we got this competition coming up, and some of you guys are competing in the contest against Robert Morgan, another school, in February. So what I'm doing is just basically going over diagrams and some scenarios, but also trying to get you to focus on when you go to troubleshoot something, how should you approach it? And that's one of the things, someone says, oh, I want to learn how to fix appliances. You have to know everything and put it together. You have to know how it works, what it does, even sounds that it makes. I can walk up and hear a specific sound and know, oh, that's coming from the transmission, or that's coming from the water valve, or that's coming from something else. But when you walk up to a machine, I had a couple machines here that you guys were practicing on with problems in them, and you guys were not actually like following steps. You were just like, oh, I'm just gonna check this, or I'm just gonna check that. And sometimes when you're troubleshooting, you can, you think this is the problem, and just say, well, I'm not gonna waste my time and go through 50 steps when I think this is what's gonna cause that. You can always go to that one part if you think that's what it is. But what if it isn't that part? How do you create a troubleshooting thing? And troubleshooting is process elimination. You have to first see what it's doing, figure out, okay, it's not filling water. In this case here, the dryer's running, but there's no heat. Then you have to hypothesize, okay, what are all the things that could stop the machine from heating? The motor, right? The motor could stop the machine from heating? Yes, and we'll go through that as we're talking about on the diagram, but there's different things that could stop it or not, and then once you've said, okay, here's my problem, these are all the things that could cause that problem, if you don't know, I see it's a bad thermostat, I'm just going to change the thermostat, then you're going to say, well, what's the best way to troubleshoot it? If it's a computer board, a lot of times just checking from the board can tell you everything. And we'll talk about that when we get to the refrigerator. But let's talk about this dryer. Runs, does not heat. So this is a Whirlpool dryer. I got several videos on it. I just picked a diagram that I had available and wrote these questions down. So it says dryer's running and not heating. And use the diagram to provide in steps that you would test, and you would test for this problem. So let's take a look at the diagram for a minute. Here. So here's the diagram. Dryer runs and don't heat. So our focus, you know what? Let me pull that into the other program. I'm going to pause this just for a second. So we said dryer runs and don't heat. What is our main focus? If a dryer runs and don't heat, what would you focus on the machine, Dave? As far as, or the diagram, what would you focus on in the diagram?
The element.
Okay, the element, or the element circuit, right?
Yeah, that's correct.
So the circuit for the heating element is right here. It goes through these timer switches, goes all the way here, and goes out. All right, so that's one of the first things you need to do on any machine that's not working. You want to go ahead and say, hey, what's working? What's not working? And then when you say, oh, the heating element's not working, what is the path that is? And anything in that line that I just highlighted right now could be part of my problem. So what do we do next?
How was it, was that thermal coupling, the first?
The thermal cutoff?
Yeah. The first thing I would do is check and see if we got power from one side to the other.
That would be a good test, but would that be the first thing you would do? Would this be the first part you would test if the dryer ran and didn't heat?
Power, of course.
Well, okay, wait, so you're gonna check power where?
Line 1, line 2.
Line 1, line 2. All right. Well, here we go. Where did you get the information dryer's running, not heating? If you're a technician, where would you get that information?
Customer.
Okay, so your interaction with the customer is going to give you clues. Okay, Now, if the customer just says, oh yeah, it's running and not heating, you say, well, how do you know it's not heating? What do you think a customer would say? Because I don't think a customer, have you ever turned a dryer on and let it run for 5 minutes and open the door and stick your hand in there and said, is it getting hot? Oh yeah, it's getting hot, and then close the door so it's finishing your clothes? So how would a customer know a dryer's not drying, not heating?
Probably did a load and everything can dry like you wanted to.
So
Okay.
it's coming out wet.
Yeah.
It's coming out wet. Now listen, this is important because I'm leading up to something. Because yes, on this particular machine, if the motor's running, how much voltage do we need to make that motor run?
120.
120 volts. And that is between line 1 and neutral, not line 1 and line 2 that the heater needs, right?
Mm-hmm.
So obviously you're going to hear just about any technician or teacher who tells you dryer runs and no heat. First thing I want you to do is you check to make sure you got the right power in the wall, right? But I'm not going to do that on this machine. Because what you guys already told me, she's got proper power in the wall. Look at the diagram and try to figure out where did that come from. Take a minute.
You know about running?
Okay, so it's running, so I'm going to do the red and say, okay, the dryer's running. But I need 240 for the heating element. I don't use 240 for the motor. But I know I got 240 also. Because what was it? We just discussed that the dryer's doing what?
It's running.
It's running and what?
It's heating, but not fully. I don't know.
Okay, go back to what we said at the beginning. The customer told you that the dryer's not drying the clothes, right?
Mm-hmm.
And I asked you guys, well, how would that customer know? At the end of the cycle, is key. Now look again at the diagram and try to take that little bit of information and what does that mean if I tell you the end of the cycle and it still wasn't dry? So what did that tell you happened besides the motor running?
The timer?
The timer motor's running. Okay? Because if the timer motor wasn't running, the customer wouldn't have said, she would have said that, oh, you know, I turned it on, an hour later I came back, but the timer's still where I left it and the clothes aren't dry. But in this case, we said, oh yeah, at the end of the cycles when I noticed the clothes were still wet. And that's what a customer will tell you. A customer can't tell you, oh, well, there's no 240 on phase 1 or whatever it is. Most of them don't know anything about electricity or whatever. So if the timer's working, and I'm going to clear this up just for a second here. Where's my erase tool? I don't know where my erase tool is here on this one. They keep messing up. Oh, jeez, I went too far back. 1 second, sorry. Okay, so here, the timer motor goes here. And if it ends the cycle, what does that mean?
It's getting to 240. So
Yeah, now this is one of those very rare Whirlpool dryers where the timer motor actually is connected to line 2 here on this top switch. On the bottom one through the heater, it always goes to line 2. But on most Whirlpool dryers, you'll find this line goes here through neutral, okay? But it would have a power resistor right there, but that's needless to say. I'm not going to get into it right now. But if the timer's advancing, I already know I have voltage. So in other words, if you're in a competition, you have to pay attention to everything in the diagram as far as before I take panels off and start making tests. I already know I got power if the timer's advancing. So when you go to someone's house, what's the first thing you're going to do? You're going to turn it on. And I put it on time dry, put it on 40 minutes, press start, let it run 5 minutes. Just see what happens. Maybe not 5 full minutes, but at least see if the timer advances. Now one thing about timers is timers don't advance like a second hand on a clock where you can look at it and actually see it moving. They move like click, and then they sit there for like a minute or two before they go click, and they do it like that. They move in very small increments. But it is noticeable where you could put it in a spot and then just wait 2 minutes and see if it moved. And that tells you already have voltage, okay? But the other thing that happens is that I told you the motor's running, right? So if we looked at that motor circuit again here, the red lines in this diagram are what we know is running. The black line is the circuit that has the problem. But what just happened there? Can you tell me something there?
The timer switches close,
Which one?
depending on the heat. It would
Well,
be
look at the diagram. Which timer switches are closed?
It would be light blue, and that bottom one.
That bottom one?
Yeah.
But that's the black one. I don't have a red line going through there, so I don't know if that switch is closed.
Oh, I thought you were.
But I
asking
do
about
know this switch is closed, right?
Yeah.
Why? Because the motor's running. So anything that has the red lines, we can eliminate as things we have to test. Okay? So taking a minute and looking at what's working and what's not working is going to help us reduce the tests we have to make. Now, let's identify what components that we have to check. We have what? Thermal cutoff? What else?
Operating thermostat.
Okay.
Dynamic thermostat, heater.
And heater.
The terminals from two, well, no. it'd be-
We don't need the centrifugal switch either.
Yeah.
But remember I said a minute ago that could the motor stop the heater from working? Yeah, there's a switch on the motor. Let me just get this motor here for example. Okay. So we have a centrifugal switch here on this motor. And if you look closely at these motors, there's all these numbers on here. Okay, you got 4, 6, 5, that's actually 3, and 1 and 2. 1 and 2 on this one, and I'll show it on the camera real quick. If you look at all the terminals, there's 2 terminals on the end on this one. Now GE is the only one that's a little odd because sometimes is it GE or LG? I don't remember now. But sometimes they put the 2 terminals right next to each other instead of across for the heating element. Okay, but if you would actually look at the pins on this motor, you'll see those pins are a lot larger than the rest of the pins. Can you see the diameter of those pins?
Yeah.
You see the pins are bigger on the ends?
Yeah.
That's 1M and 2M on the motor. Those bigger pins on the end. Okay? And those pins are the one that complete the circuit for the heater. Because if the motor's not running, we don't want the heater to come on. So that's why they put that switch in there, because we need airflow, we need the drum tumbling and the clothes moving in order to check that out. But look how much stuff I eliminated just by turning it on and running and know it's working. I've eliminated power coming in. I've eliminated one of my timer switches here. I've eliminated my centrifugal switch just by saying, I see these parts are working and these parts are not working. Remember, your meter is just like the motor in the dryer. If the motor is running, I know I got 120 volts. Well, it's just like putting a meter in there and reading 120. So use the components in the machine that are working to say, well, I know that circuit's good and that circuit's good because this part would not run. So going here, basically, you would just check these parts. So normally you would check voltage coming in. But that's not our problem in this case. Our problem is one of these 4 parts here. We forgot one thing, right?
The bottom timer switch.
Timer switch A. Okay? So the next thing was, what would be the order which you test? So the very first test you should make is turning it on and visually inspecting it. If you do that in a competition where listen, this thermal fuse here, you talk to any technician with experience, says, oh yeah, customer calls, said Whirlpool dryer won't start. It's either one of 2 things if it's not a power problem. It's either the door switch is bad, or the thermal fuse is bad. And 9 out of 10 times that thermal fuse is what's failed. I don't know how many of those thermal fuses I've changed, but the thermal fuse is why the motor's not running, okay? But a technician's experience may walk right up to the machine and see that, hey, I'm pressing start, I open the door, I hear the door switch clicking, so let me go to the thermal fuse and go check the thermal fuse. That's the first thing I'm gonna check, okay? Only because I've done it for 40 years, okay? But if you are not 40 years of experience with a specific machine, you have to come out through this steps here. And your first test is visual to see what's working and what's not working. That is a test. Just because you're not taking tools out or meter out to do that, that is your test. And if a judge sees you go right to the thermal fuse and you walk up to the machine and say, oh, it's either the door switch or thermal fuse. I open the door, click, click, go back to the machine, take the back off, check the fuse. Yeah, Judge, I found the problem. It's bad thermal fuse. You know, you're 30 seconds into the competition. Some judges will be like, yeah, but did he really check it properly? He got lucky and went right to that first part. Okay? So when we're troubleshooting this and we circled the parts that could be part of the problem, what do we do now? We turned it on, we saw it was not heating, we saw the motor was running, we knew the timer was advancing, so we know we had correct power. What's the very next step that we would make after we visually inspect what is working, what's not working? Anybody get any idea?
Thermal couple, the power. So they give 'em
The
extra-
cutoff?
Yeah.
Check the
Re-
heater.
Really, you want to go right to the heater first.
Mhm.
Okay? Whatever load is not working on a machine, customer tells you, hey, my washing machine's not draining. Yeah, it could be a bad door switch, but you want to say, and I got power down to my drain pump. Because I got power to drain pump and the drain pump don't pump out, drain pump's bad. If I don't have power, yeah, any one of these parts could be, but you know what? This part, this part, this part, and this part, we're all right there in the back of the machine. They're all right next to each other. The only one that's not right next to them is the timer switch. So I'd save that as the last part I would check. But the very first test I would make is I would go right to the heating element with my meter, and we want to get alligator clips. So some of you guys competing, if you can get alligator clips, if you have meters, go on Amazon, and I want to make sure that you get two things. You want to get alligator clips that can slide over your meter leads, so you could clip the meter onto the two terminals of the heater, then plug the machine and press start. We'll practice that when we come back after Christmas, okay? But the other thing you want to get are those little computer leads, those real skinny leads that can get on a plug on a board, because sometimes your leads are too fat and they can't get in anywhere to make a test, okay? So we're going to check voltage here. If I don't have voltage here, how do we troubleshoot this? Do we just go to each part and say, okay, I'm going to check this part, I'm going to check this part, I'm going to check that part?
You go to neutral with 1 meter lead, and then you'd go back with your other meter lead, checking voltage.
I don't know why I don't see my eraser tool here. See that, but where's the one that clears the whole screen? I tell you, every time they mess this up. So say that again, Manuel, I didn't hear you.
You'd go to neutral with 1 meter lead, and then you check voltage back to each component with the other one.
Okay, that is definitely wrong.
Word?
Yes, and a lot of people say that, and I'm gonna explain to you why, okay? We're gonna talk about a simple 240 volt circuit, and we'll get back to the heating element. A simple 240 volt circuit, I'm gonna have a switch, a heating element, I'll put another switch here and here. It's like a stove, the cooktop element on the stove, you have your element, and you have your infinite switch has 2 switches in it, one on the line one side, one on the neutral side. Let's say that this switch is good, it's making contact, but that switch is open. This is line 1, this is line 2, and let's just say neutral's right here, or ground, right? If I put my meter here and here, what is that meter going to give me a reading of? Right now, in this circuit, the way it is.
120?
0. I have voltage there, but this is all part of the same circuit now. Line 2 goes all the way over to here and stops. You're saying, yeah, but when I close the switch and line 1 here, that means line 1, line 2 blow up. No, well, this is the dividing line when the circuit is complete. But there's something called potential voltage. Okay, let's just say you got a water hose and you got like a little motor that spins, and then you got more hose after it, and then you got a valve, but the valve's open. Well, if you put water and it goes through the motor, it's going to go all the way up to the end where that valve is. So there's potential there. There's water already there, and that's the same thing with voltage. So if I put my voltmeter here, and I put the other lead to ground, so I'm on one side of the element and ground, what's my voltmeter read?
120.
120. If I put my voltmeter here and ground, what is it?
120.
It's 120 because it's feeding back through the element. Now you say, yeah, but you can't really go through the element because the voltage would drop because it's got resistance.
Right.
When there's no current flow, you do not get the voltage drop. It's the same thing like your sprinkler, or not your sprinkler, but your hose, and you got like one of those spray guns on the end. You turn the bib off on the wall, but you don't pull the trigger. The hose is filled with water and it's under pressure. You pull the trigger, there's pressure there, but then it drops when it flows. Okay? So in this case, when it's off, it still has full pressure right up to that point. So how much voltage do I have here to ground?
120.
How much do I have here to ground?
120.
So in a 240 volt circuit, it doesn't matter where your meter lead is located, you're going to have 120 volts to ground or neutral all the time. No matter where it is, even if the circuit's bad. Okay, now if both of these switches were open, this one and this one was open, I put my meter to ground, I'm going to have 0.
Right.
Okay, but if you're checking a circuit and the circuit has a problem, it doesn't matter what side. If this switch was the fault and that one was good, it would work the same way. All the way back up to line 2 to ground. Everything's going to give you 120. So 120 or the circuit to ground on a 240 volt circuit will never ever find the answer for you. The only way you're going to have to do that is put both meter leads here, because when my meter leads are here, what's my voltage reading? 0. Because they're both line 2. And if I move this meter lead here, what is my reading? From here to here?
0.
0. But what if I move my meter lead here and here? Now it's 240 because line 1 is to here and line 2 is here. What if I have my meter lead here and here?
240.
240. But we don't want to put our meter leads across any switches or controls. Our meter, we want to keep it where the load is, and the 2 leads are getting its power, and we're looking for 240. Okay? So when we're checking voltage, we're checking a 240 volt circuit, we want to go right to the heater and look for 240. So if I don't have 240 there, what do I do next?
Take one of your meters and keep going back.
You only take 1 meter lead and you slowly go back to the next point on the diagram closest to where you are. Because I'm on the heater, I'm just going to move it over here to the thermostat. What if I have voltage here but I don't have voltage there?
If you have voltage there and you don't have voltage there, then the wiring between them is up.
There's nothing wrong with
Exactly. And this is why we want to go load, wire, control, wire, control, wire. So this is voltage coming in, this is voltage going out. If I don't have it going out, but I have it going in, the problem is here. And when we're troubleshooting, we want to have 1 meter lead. That's why alligator clips are good, because I can clip one meter lead here and just move the other one, clip it, turn the machine on. Now, in the competition, you should do this in the customer's house too, is that you unplug the machine, you move your meter leads to your next test point, plug it back in and do the test. Now, you could go to the heater and go like this, and go like this, and go like this, but the problem is that on a dryer, you have, on the back of a Whirlpool dryer, you have the heating element here, you have a thermal cutoff here, high limit thermostat, your elements here, and your operating thermostats here where your blower fan is, and the air comes out. So you have a thermostat right here, not there. You have 1, 2, 3, 4 parts right there. And you put your meter lead on one of these terminals here, and you touch here, 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 and just keep going back across till you find out, oh, I have voltage here, but I don't have voltage on here. That's the problem. If it's good, I have voltage here and here. But I'm always leaving one meter lead at that one point. Okay? Now, I don't have a specific problem in the diagram and say, oh, well, the problem was the thermal cutoff and you got it right. You know, that wasn't the idea. The idea of this exercise was to get you to think about what was the complaint, how do I look at the diagram and use that diagram to give me enough information to start making tests and to start checking. Let me, dang it, I wish I could figure out how to, is that erase? I don't know how to erase now here. Tools. More tools. Let me just see if I can find, it was like a little spray bottle that I had that I used to erase everything. I'm mad now because I can't figure out how to get it out of here. Let me just get this eraser here and I'll just erase this like this. I'll have to. Okay, I got one other thing I want to talk about relations to the heater, and then we'll move to the other question. So guys, if you have questions, ask me if you have any questions about what we're talking about. Okay, so let's just say that in this case, it doesn't heat, but the timer's not working also. Okay? Then we would look for what kind of problem. What kind of problem could it be? Anybody got any ideas? Take a look at the diagram. I told you dryer runs.
No power?
What?
Would be no problem. Power?
It could be the power, but specifically what power?
240.
Yeah, well, specifically line 2, right?
Yeah.
Because if line 1 would stop the motor from working, right? So that's not my problem. Is there anything else that could be my problem?
The switch going from white blue to white black.
White blue to white black, can you be specific?
The switch right
Yeah,
after
but
the-
that white blue, white black has nothing to do with my heater. It's only for the timer motor. I said both of them are not working right now. So it's not that switch there. How about the centrifugal switch on the motor? Do
Yeah.
both of them require that switch in the motor to be good in order for it to work?
Yeah.
Yep.
Okay, so that's that. That's good. How about this timer switch?
Yep.
No. Why?
Because the timer motor doesn't run off it.
The timer
Yeah,
motor
but the
doesn't run
heater
off it.
does.
So again, what I'm trying to get you guys to key in here is to look at if there's multiple parts in the machine that are not functioning, like the refrigerator, like the problem I had over in that refrigerator over there, is that there was more than one part not working. So we don't go down to that one part. We look and say, what in the diagram could stop both parts from running? You know what I'm saying? That I'm not going to worry about this thermostat. Yeah, it would affect my heater, but it wouldn't affect my timer motor. My timer motor would still work. So looking at what it could be, cannot be. But let's just say,
Unless there's more than one issue.
what?
Unless there's more than one issue. They both have separate issues.
It could happen But if the timer wasn't advancing, do you think the customer would use the machine 10 times before they call and say, hey, I got a problem? Sometimes they might, sometimes people really tight on money, man. I can't call, but it still runs and heats. I'll just turn it on and come back in 30 minutes and check my clothes. You know what I mean? But, the odds of 5 things being wrong with a machine. I was going through some tickets on my guys, and a guy went to the customer's house and said this wasn't working, and came back today and said, oh, well, this is not working now, and he ordered the motor, the clutch, the shifting mechanism, and this and that. And I'm like, really? All 4 of those parts just went bad? Did he even bother to check it? Now, in this thing here, let's just say the heater's not working, and let's just say for the heck of it, the timer is 110 and not 240. So we don't know if we have a 240 volt problem or we have a problem within the machine. So we want to go and say, okay, I check here and here, I have 240, right? Where do I go next? If I have power here, what's the next test to make? Dryer's not heating.
Heater?
What?
Heater.
Heater for what?
For resistance or voltage?
Voltage. We want to do every test we can possibly make with voltage. When I go there, if I am checking, am I testing the heating element right now? If I put my voltmeter right here, am I checking that heating element?
Yeah.
Do you all agree on that?
Yeah.
You all agree I'm checking the heating element? Well, you're all wrong. I'm checking voltage. Does the heater create voltage? The heater needs voltage to work, but when I'm checking voltage, I'm not testing the heater. We do that for ohms or continuity. So when I'm doing a voltage test, I'm checking the circuit. I'm checking the circuit coming down to the element that's bringing power to that element. Okay? I'm not checking the element. That's continuity or resistance. If I have voltage here, do I need to check the heater for continuity?
Yes.
No.
No.
If I have voltage to the heater and the heater's not working, there's nothing more left. Having voltage there is telling me this switch is good, these cables are good, these switches are good, and everything's good up to. If I have voltage, that's all good. The problem is right there. So that's why we always want to follow the load, because the loads on most cases are the parts that fail the most often, because the heater's always getting hot and getting cold, and hot and cold eventually burn out, especially if they have bad airflow in the dryer. So when we troubleshoot that, let's just say my meter said 0 volts.
What do you mean by bad airflow?
Well, if you have bad airflow, your element would start to sag and go bad prematurely.
That's when the little filter.
Well, yeah, you pull the filter out, see if you got airflow there or whatever, but maybe the hose in the back is crushed, maybe the vent going out to the customer's house is bad. It's still heating, taking long to dry, but it shortens the life of your element. That's what I meant by that. That the element just can't take that excess heat without that airflow. So I'm checking that and it says 0 volts. What do I do? Dryer runs, no heat. I have 0 volts.
You get no volts?
Hmm?
That means there's a volt.
Moving back, change it.
Replace it.
Well, we backtrack, right? But which way? Because it could be here.
I'll go right first because it's
Or
the
it could be
shortest
here.
distance. I'll go towards the shortest distance, get that, knock that out.
Well, no, that if you're going right, if you mean to the switch to there, the switch is going to be up top behind the thing. Everything else is going to be closer to your left.
The
Like
switch is going to be, what switch are you
The switch
talking
is going to be the centrifugal switch, right? You'd have to check underneath.
That's
it.
on the motor. That's down right on the bottom, but it's
That's
in the
gonna be-
front of the dryer.
Correct. It's
And
completely
you're in the
opposite.
back.
Exactly.
Now, on some machines, the motor and the heat element are in the front. Okay? They're not all in the back like a whirlpool. Okay? But let's just take a look at this for a second. Let's do that dryer drawing I had again. Here's your control panel up here, you know. Heat element. Your thermostats, your blower housing, you know, and the thermostat right here. And you go right here on the 2 heater wires, and you got 0 volts. Well, it could be all these parts, it could be a timer, it could be a centrifugal switch on the motor. But instead of starting to test everything, I go right back here, 3 screws, and I leave 1 meter lead there. I take the other lead, put it on L2. If I don't have voltage there, I put it on L1. Whichever side gives me 240 volts is the side that has my problem. Now let me show you on the wiring diagram what I'm talking about. So I'd have my 2 meter leads here. I need to know which way my problem is, but instead of starting to test like this, or test like, I can't get to that motor without taking the machine apart. But if I take this meter lead off and go from here to here, and that is my problem, right now it'll say what here? What will it say here if this is what's broken? What would it say?
0.
0. But what if I put it here?
It'll be
It'll be 240. Then I know my problem is here. Does it make sense?
Yeah.
Now I don't have 240 here, but I have it here by moving 1 meter lead. And that would be those 3 screws on the back of the machine, the L2 one, the red one. The black one's over here, L1. So I move this meter lead here and there. It doesn't matter. It doesn't matter which one I move, because remember, the voltage will flow through the heater like I just showed you in the other part. So it does say, well, I took this one to L2 and I'll bring this one back and move that one to L1. I don't have to do that. I can take this one and go to L2 or L1, but whichever one gives me 240 volts, that is the direction I go for troubleshooting. Remember, this is not all about see if you can find the problem in the diagram. This is how do we approach the problem in the diagram? How do I know I'm going to go that way and check that? Or how do I know I'm going to check this? The diagram tells you all the parts that could fail to stop it from working. But now you have to say, how do I use my meter to determine which way? Any questions? That was number 1. See how much, just that simple little question that it has to do with that? I wish I could clear this thing. I don't even know.
Control Z maybe?
Control Z, you think it would erase
It's
it?
not gonna clear it, but you can go back. Well, you can do the arrow key on your thing too. I don't think that matters too much.
Well, the way this thing used to work, that if you hit the eraser, and you go like this around all of it, and tap, it would erase. But it don't work. I don't know. I just don't get it. It's like, they mess this program up, and every time I try to add the tool, the school system updates it, and then it goes right back to the stupid thing here. So, let's look at problem number 2. What is problem number 2?
That doesn't run.
That the dryer doesn't run at all. I'm not gonna go just so you can read it, but the dryer doesn't run. All right, so what's the first thing we're gonna do?
Check the power line?
Huh?
The power line?
No,
The motor.
no,
Take the power to the wall.
no.
Fuse?
Turn it on.
Oh,
Yeah, but it don't turn on. Try every cycle, try every button. Open and close the door. Check everything is okay before you just start making tests. Don't start taking anything apart. Don't start doing a bunch of tests until you've tried everything and saw what was working, what was not working. Timer motors. You can hear a timer motor going even though you don't see it moving, or you can even feel a vibration sometimes if a timer motor is running. Let's just say that timer motor again went to neutral. Well, as soon as I turn the dial of the timer, this switch closes, power is going to go from my timer motor. Even though the motor itself is not running. But if the timer's advancing in the circuit the way I drew it, And that's not the correct circuit, it goes that way, I'm just showing. But that, we know that's good, right? So again, try everything you can to get the machine to do the problem to determine, is it this or is it that? All right, so now let's go through the steps here. Well, it's Control E and I can bring that eraser up. I just wish I could finish, there's a tool, it's one button, it clears the whole screen. I just can't figure out how to get it on the screen right now. So dryer runs and don't heat. So let's just say, okay, we go here and this is my circuit for the motor. The motor is going to be very hard to get to on a Whirlpool dryer. You have to lift up the top, take out the filter, you have to remove the front of the machine, maybe take the drum out. Let's identify what components would stop this.
Thermal fuse?
Thermal fuse. What else?
Operation terminal, thermostat?
Does the motor need that part to function, the operating thermostat?
Timer switch B.
Only what's highlighted in red, that's the circuit for the motor. Those are the components we will test for troubleshooting. We're gonna check black to blue on the timer, the thermal fuse, the push to start switch, the door switch, and then eventually the motor itself. So where do we put our meters, Emmanuel?
Put your meter lead, probably at the end of the door switch.
At the end of the door switch, specifically where?
Going on the white wire.
Okay, I'll put a meter lead there.
Sorry, I can't see.
Where I put my other meter lead?
On the other side of it, and then you'd go back. No,
You what?
on the other side of it, and then you'd go back.
On the other side of what? The door switch?
Label it, because I can't see that.
We don't put a voltmeter across a switch. We put a voltmeter across a load. A meter is just like a motor.
Mm-hmm.
The needle moves, it's just like the motor that runs. So we want to go to the motor, but the motor's too hard to get to. So what we do is that, how close can I get to the motor without actually being at the motor?
Light blue right after the thermal fuse.
Well, what I would do, honestly, only because these two components are right next to each other, is your timer and your start switch are both in the control panel of the dryer. Okay? So I'm gonna go here and here for voltage. When you're doing that, obviously the timer has to be in the cycle, but I have to press this button to close this switch. If I have voltage here and here, now what does that mean? Dryer's not working, but I have voltage here and I have voltage here.
That means you'd move forward towards the thermal fuse.
So it's either the thermal fuse or the motor, right? In a competition, they don't want to put no wire, so it's not going to be, oh, well, it's the wire between this and that. They don't like to do that. So it's either this or that. So now the thing is that we picked a point as close to the motor as we could get without actually going to the motor. All right? If I don't have voltage here, well, it's right here or back to the door switch. But now I've narrowed it down. Okay? I'm not going to do much more about that. Do you have any questions on that? I'm going to be putting all kinds of problems in when we come back from Christmas break. And I'm going to watch you guys more for the way you troubleshoot it. Not even, oh, did you get it right? And did he get it in 2 minutes? Speed is not always the best. And the thing is you never know what a judge is looking for. When a judge is watching you, a judge is looking at, if that guy's working for me, how would I want him to confirm that those are the problems? Now, if it's your business and you're experienced, how would you want your employee to do that? Okay? So any questions on the dryer before we go on to the refrigerator? No? Okay, well, the next quiz I give you guys when we come back, let's see how well you guys do at that. So, the first statement on this is what? What is the first question?
The evap is
Defrost
running
over.
over thin ice on the evap.
Let me see if I can bring it up and read it. Just refrigerator has an obvious defrost problem. So I'm telling you right now, it's a defrost problem. It's not defrosting. What am I looking at? If I'm telling you it's not defrosting, what is it that's telling me it's not defrosting?
Frost the lip of the evaporator.
It'd just be covered in ice. The whole back freezer would be covered in ice, okay? So, how would you test that? Let's go back to the diagram. So, first thing I want to know is my heating circuit, right?
Mhm.
So, I'm not going to draw all over it because power comes in, goes through a relay, and pink is defrost, and it goes here to the bimetal and through the heater and out. All right? How many components do we need to make up defrost?
3.
3. In all circuits, there's a minimum of 3. Now with these newer R600 units, they put fuses on the heaters. Now, they haven't had fuses on heaters in a long time, except for Avanti was a small appliance company, and Avanti made like small refrigerators, like efficiency style refrigerators, and they put thermal fuses on the heater in case the defrost thermostat didn't open, but that's very rare you'd see that. So how would we check these components?
Black and white right after the defrost heater.
Wait. Black and what?
White right after the defrost heater.
Well, here's white. Where am I going on black? Where am I put my meter lead?
Line 1 before the relay.
Here. But you're not going to be able to get to that white one on the defrost heater because the heater's buried in ice. So you're going to have to defrost the ice just to get to those wires. But guess what? That defrost thermostat is also next to that heater. What closes that thermostat? When it's hot or when it's cold?
When it's cold.
When it's cold. But in order to get the panel off, I gotta melt all the ice, right? So once I start adding heat, that's gonna open up on me. So that's not where do I put my meter to make my test? I know you know it, man, well, you just don't wanna say it, because you already know it. We had this discussion. Anybody else?
Black on the relay.
Black on what?
and pink on the relay.
Black or pink on the relay? No. Remember, black and pink is a switch. Now, we're doing voltage testing. Why would I voltage test that switch? Where do I say we voltage test? Across what? The load, right? So if we,
Could we do pink and brown then?
well, let's take a look at it. Where pink and brown? Pink and brown is what? My defrost thermostat. Where's voltage supposed to be? At the heater, right?
Mhm.
And what 2 wires go to that heater?
Brown and white.
Brown and white. So watch this. If I go this way, I got brown here. And if I look at this white, doesn't it go back to here? And I could put my voltmeter right there on my timer, and that would tell me if I got voltage to my heater.
Yes.
If I have voltage there, no ice melting, what's wrong? Heater's bad, right? But what if I have 0 volts there? What could the problem be? The thermostat? So where's the next test to make after that?
Is it the fan?
Hmm?
The evaporator fan?
Fan has nothing to do with defrost.
Well,
We're saying the heater don't work, but I don't have voltage to the heater. So the fan doesn't send voltage to it, but we have a thermostat here, right?
Mm-hmm.
So where am I gonna put my meter now? Come on, man, where are you gonna put it?
Think what
Where?
on the electronic defrost.
Okay, so I'm on brown and white originally, and that was checking this and this. And now I'm gonna move this one, make it harder to work than anything else. I'm gonna have to figure this out. I'm gonna go pink. If I have voltage here and here, but not here and here, what's wrong?
That means that you have a wire in between that is damaged. No.
No, the bimetal's bad.
Oh.
Because I was brown and white here, which was really just checking voltage here, but at this point. And I didn't have it. So now if I want pink and white, now I'm here and here, even though I'm physically on the board, that's what I'm testing. If I have voltage there, but I don't have voltage there, it's most likely a bad defrost thermostat. Right?
Yeah.
But what if I still don't have voltage? What's my next test? Black
Black thing.
and white.
Oh.
If I have 120 there, but not pink and white, the relay on the board's bad and the board's bad. But all three of those tests can be made right here on this board. I can ohm out the heater. I can ohm out that thermostat. They even have something called a test terminal, which is just a plug that you could jump out and bypass that heater so the bypass that thermostat so that the heater will defrost the unit. Does that make sense?
Yeah.
Now, here's the thing. All this information, all this stuff that I'm talking about, and you guys are looking at the diagram and say, how are you coming up with this? How do you know to go here? How do you know to go here? I know how this part works. I know how that part works and how that part works. I'm looking at the diagram saying, well, that pink wire is this pink wire, and that brown wire is this brown wire. If I put my meter here and here, I'm checking this part. And that's what we need to do when we're looking at a diagram. And you're like, well, how do I get that information? You don't get that information. I could stand here and talk diagrams all day, every day, and if you don't know how the machine works and what the parts are doing, you'll never put it together. But that's how we have to do this. We have to constantly look at the diagram, look at the machine, and see how they go together. So let me clear this up, and we'll do the last problem. What's the last problem while I'm erasing?
Lights come on. Unit doesn't cool.
Okay, so
For the spec sheet of preference,
It's not that it doesn't cool. It's doesn't cool at all, and the fans aren't running and the compressors are running.
okay, but the light comes on, and by opening up the door, we can see that, and that lets us know that there's proper power to the machine, right? If the light comes on.
Yeah.
So, no cooling. We have both a fan motor and a compressor. Neither one of them are running. So is the problem my compressor or the fan?
It's the thermostat.
It's neither one of them. You have to look for something like the thermostat, like this, that sends power to both. But is it just the thermostat?
There's also the electronic defrost control.
It's this relay here, black to orange. Power comes in, goes down, and goes through here. But when you have multiple parts not working, and I said the same thing with the dryer, if you have more than one part not working, look to see what parts in that machine you can say controls all of them. And that's all you need to test. Is there any questions on this? I could go further and say, well, we just ohm out the thermostat or ohm out the relay on the board or jump it out. But that's how you would test them. No questions? You guys gonna do good on the test when you come back in 2 weeks? Study these diagrams because some of the questions are gonna be off of these two diagrams yet, so I'm gonna add some more. That'll be it for today.